So I just wanted to check with you guys whether you guys can see the tutorial letter. Let me just check something with you guys. So there's a section there. Let me just enlarge this. There's a section there that they say overview of the module, unit 1, chapters to learn, they say. Chapters to learn, chapter 3.3, 3.4, 3.5, 3.6, 6.1, 6.2, 6.3, 8.1, 2, 3, 8.5. So this is my first time I'm presenting this module, but I should be familiar with all the topics here. I think you guys go up to linear algebra also, some matrices. Yeah, and okay, Cramer's rule, and then binomial theorem. Okay, that's fine, and then that's okay. So I just don't want to, and there's some complex numbers I see also, what you guys do, and then division. So I just want to have a sense of, because I suspect that you guys should be beyond the dividing polynomials, you know, those theorems, the remainder theorem, those theorems relating to the division of polynomials. I suspect you guys should be beyond those theorems, the remainder theorem and the factor theorem. I suspect you guys should be beyond that. So I just don't want to dwell on stuff, and I'm not sure if you guys finished your first assignment and up to what it was. So yeah, so I just wanted you guys maybe to say something. So with regard to chapter 3, I suspect you probably would have handed that in already, the assignment related to that. I'm not sure about chapter 6 though. As far as I can see from the textbook that I'm using, your chapter 6 should be on complex numbers. But from what I'm using here, it's initially, I think it's mainly trigonometry. Yeah, trigonometry. Yeah, trigonometry. So I'm not sure how far you guys delved to that, to the trigonometry, and then your chapter 8. Well, my chapter 8 deals with complex numbers and so forth. So I don't want to belabor the issue and go back to chapter 3, and you guys have done it, unless there's some questions you want to ask me specifically. So I trust that you guys will inform me how far you are. I have no idea how far you are with the course now. But I would assume that you're done with dividing polynomials, the factor theorem and the remainder theorem. Oh, okay. And then I see that you guys don't go to trigonometry immediately, you go to complex numbers, yeah, the fundamental theorem of algebra. So I'm not sure if I would be jumping the gun if I were to go to complex numbers immediately. Can I just have a sense of who's working on complex numbers currently? Oh, maybe let me just ask first. Did you guys finish the first assignment that you submitted it already? The first assignment? Okay, Junior? Okay, Junior?
A question about the first assignment, then I say.
You have a question regarding that?
Yes.
Was it submitted already?
No.
Is it okay? Maybe I can just guide you on it then, okay? Let me just guide you on that question, because I do not have that question. Those questions, they do not appear in the tutorial letter, am I right? They don't appear there, right? In this letter that I have in front of me. Let me just check. I didn't see that happening there. So I think this is just a letter to say welcome to the module and stuff. Okay, so I don't have that question. Maybe you can give me the question. I can write it on the whiteboard. Let me just share it on the whiteboard, Junior. Share. Okay.
It's about the PDF.
About what PDF?
The first assignment.
Okay. So yes. So it's not in tutorial letter 101, right? It's not in tutorial letter 101.
Yes, I wasn't given the PDF. I was only given the special number only.
Oh, okay. Okay, with those methods, you'll have to be in touch with the lecturer concerned. I think in tutorial letter 101, you have the details of the lecture there, okay? So I can't help you with those things. I thought maybe you had a specific question relating to the, you had a content question, because this is an administrative question, and I'm not the best person to answer those things, okay? Ms. Pram, can you hear me there, Ms. Pram? Okay, so Junior, I'm not sure, maybe you can get in touch with Ms. Pram. I doubt it though, but the best person to talk to would be your lecturer in that case, okay?
Okay,
because
thank you.
I thought you had maybe a specific content related question that I can maybe just guide you on. Okay, sorry for that, Junior. So just maybe get hold of Ms. Pram or the lecturer then concerned. Okay, guys, can I check with everyone else whether there were any compelling questions or where you guys got stuck? Because I don't want to just start with complex numbers and stuff and assume that you guys are there already. I can start with it, introduce it, and maybe you can start asking questions around it. Okay, let me just check the chat. Okay, Nazipo, can you see the screen now? Nazipo? I haven't shared anything. I've just shared the tutorial letter 101, right?
I can see it, Dr. CS.
Okay.
I can't see the screen.
Oh, was it okay? Because I was
Might
just
be your connectivity, student. And if we can have any other students, can you see the screen, students? Yeah. If all of us is seeing it, then it's possibly your connectivity. Perhaps you could just move to a better space.
Oh, all right, thanks.
Thank you.
okay. Then, so what I would propose then, guys, is seeing that you guys don't have specific content issues on the chapter relating to the division of polynomials, long division, the remainder theorem, the factor theorem, and etc. I will then jump into complex numbers, and you see, I can't even tell you what your assignment 1 was on because I don't see that in tutorial letter 101. But from here, let me just see assessment. Can say that sources closing. Okay. Study plan. So the study plan, let me just see the study plan. Okay, it doesn't go there. Okay, great. Okay, guys, so what I will do then is jump into complex numbers, and I'll just try and summarize it quickly for you, and then I hope you guys have some questions for me on that. If there are any other questions, guys, feel free to ask, because I do not know, because you work at different rates, of course. You don't work at the same pace. So I can only surmise that you guys would be busy with chapter 6. Others are probably busy with chapter 11. It's plausible, okay? But feel free to ask me a question to stop me at any stage, or to ask me a question, not to stop me necessarily. So what I'll try and do is go on with proceed with complex numbers, okay? I do not have the study guide, but I'll just use it, summarize the basic facts of complex numbers for you guys, okay? And then if there are any questions that arise, that's fine, you can ask it, right? And then if there's someone working on trigonometric functions, maybe identities, etc., they have some compelling questions, etc., it's fine, they can also ask that, right? I don't have a problem with that. Or any other questions that you guys feel. And then I think from this session, I can then just have a better understanding of how far you guys are, right? So feel free to ask me a question, guys. So what I'll do now, let me just see if there anything. Right?
Yeah, so I'm not sure where others are, but for me,
yeah,
I'm still far off from assignment 1. It's still upcoming.
Okay.
And on my side, I'm still on the previous chapters. So I wouldn't mind Prof running through the previous chapters if it's convenient for the rest of the colleagues.
Yeah. Okay. So who am I talking to now?
I was speaking to Pumlani.
Pumlani Glamalu.
Yes, Prof.
Is it? Okay, Pumlani. So what I'll do is, I think me and you probably need a one-on-one consultation. You can set up an appointment, and then, because I was really hoping there would be more specifics, you know, if it was work related to the older work, to the older chapters, to the previous chapters. I was really hoping that you'll have some specific questions after going through the work, you know. So I didn't mind. Is that fine? Eh? And then you can just maybe contact Mrs. Prim and ask her to set up a one-on-one consultation with me, which is usually I'm open on a Monday from 5 till 7 in the evening. Okay, on a Monday, and it's half an hour. They permit half an hour. Okay, so what I and like you correctly say, I don't know how far I myself don't know how far the others are, but I suspect that they should have finished that chapter 3, the relevant chapter 3. And from what I can see in that learning guide, and I don't want to belabor this issue, in that learning guide, they should be busy now with complex numbers. When is the due date for the first assignment, guys?
For me, it's due in May.
Is it in May? Okay, Pumlani. So what I would like to ask you is when you set up that appointment, try and maybe divulge specific things that you would like me to look at. You know, I'm just fearful of a situation whereby I discuss things from scratch and others lose interest. Okay, so I would really appreciate it if there are specific things, even for the rest of the students, if there are specific questions that they want us to look at, maybe on complex numbers also, on trigonometry, whatever, on vector algebra. If there are specific questions, or then I can just guide them how to solve the problem, rather than me starting from scratch, because this is not a lecturing session, guys, okay? It's just a facilitation session. So, but of course, with the complex numbers, I can just give you a quick run through of it. And then I'll wait for some questions. Unless everyone is saying they're having problems with the division of polynomials, then I don't mind going through it step by step, then, which will be a bit time consuming. Okay, so can I just have a sense from people how far they are also? You see in the chat. There's nothing in the chat, so I don't know. I'm a bit hesitant to start with chapter 3.3. Because I might just lose people. But let me just say one or two things there maybe about dividing polynomials, the division of polynomials. Let me just say one or two things. Maybe just write down some definitions and explain it quickly. I think it's okay. If you say the assignment is due in May, then I suppose there's no harm in doing that. Other people must just bear, in the absence of questions from their side, they must just bear with me. So I would like to share the whiteboard with you guys. So with and you'll see with polynomials, the division of polynomials, the solution of polynomial equations. It's a very useful field, and it's a field of study in its own right. In fact, there's a higher theory on it called Galois theory, which deals with these kinds of things, which you guys maybe will encounter in postgraduate studies if you proceed that far. And also in number theory, it comes up these things. So there are some notational devices that we need to know, that we need to be aware of. So I'll try and give a quick rundown through it. So this is, I think 3.3. And I'm using the 6th edition of the prescribed book, okay? This is from the 6th edition. And do not stress about that, guys. It's really not relevant. The fact is that these topics won't change much at this level, the content. It's just there are new pictures and maybe new approaches or further approaches, right, to that. But the essence remain the same of this. So with this section, it's called dividing polynomials. I'm going to try to be very brief with it. dividing polynomials. So I'm not sure if you guys can do your long division. I'll do it the classical way, the classical approach. So this deals with the division of polynomials, right? So there's this, what we call the division algorithm. The division algorithm. So in this case, you have this kind of situation. You have a function p of x divided by function q of x. And we refer to this one as usually the dividend, although I don't like that term, but refer to the dividend. It has that accounting feel to it, which I don't like. And then q of x is normally called the quotient, which I don't have a problem with, the quotient function, okay? Q of x is called the quotient. Now, after you divide q into p, I mean, it's like if I were to divide a number, let's say I divide 5 by 2, it goes in there 2 times, and the remainder is 1, okay? So 2 times 2 plus 1. So 2 divides into 5 2 times, and it's the same kind of thing here, where I have my p of x is equal to a function, a divisor called d of x times q of x plus r of x. So with polynomials, it's the same. So we have polynomials p of x, polynomial d of x, polynomial q of x, and polynomial r of x. Now, as I said, we call this one the dividend. We call this one the quotient. And this one here, the d of x, is called the divisor function, okay? Or just the divisor. Right? And this one is called the remainder. This one is called the remainder. The remainder usually has degree 0, meaning there's no remainder, or maybe let's say it has degree 0. It can also mean it is just a constant, because the constant has degree 0. And so that's the quotient divisor, and this part is, I said, the remainder function, okay? Pretty much like when you deal with integers. So you have your dividend 5, you have your 2 as your quotient. This 2 here is my divisor, and 1 is my remainder. Pretty much in the same way. And then in the book that I'm using, they have a nice example of how to see these things actually more concretely. So so there's this example on long division. You see an example on long division. So people here, we are dealing with what we call polynomial functions, okay? Or just functions in general if you want to. So these functions are all dependent on x. X is our independent variable in this case. So there's this example 1 with this nice example. It says divide 6x squared minus 26x plus 12, divide that by, so this is my dividend, and I must divide that by x minus 4, linear function. Okay, this is my quotient. This is my quotient. This is my dividend. Okay, right. My dividend, p of x. Let me just call it p instead of d. This is my p, my dividend. And then what will result from that is my divisor function and my remainder function also, okay? So this is my p of x, this is my q of x, right? So let's just do this long division, and I want you guys to pay careful attention. It's something that you guys would have encountered earlier, perhaps at school, but you should have encountered the long division at some stage, division of polynomials, okay? Right. So what I'm going to do is I'm going to solve this problem quickly, doing the long division thing. And then I'm going to ask you if there are any other questions on other sections every time I do that. Just to make sure I don't lose everyone else also, right? So when you do such divisions, you look at x to the 1 here. You look at x to the 1, and you ask and you look at the highest power occurring in 6x squared minus 26x plus 12. And the highest power there is x squared. In fact, so the term we consider here of dividing the x into is 6x squared, okay? So we divide it into there. So we'll divide this x here into 6x squared and see what happens, okay? Right. So x divides into 6x squared 6x times, because 6x times x is 6x squared. And then what we do is, and it's an algorithm, it repeats itself. And then what we do is, this one in the top, we'll multiply by x and we multiply by -4. So we'll say 6x times x, 6x squared, and 6x multiplied by -4 is -24x. And then what we do, we subtract the bottom, we subtract this part. So the signs will change here. The signs will, this minus will become a plus, and this plus will become a minus. And then we add them, okay? That's what's happening. So we do a subtraction basically. Subtraction means the signs of this here will change, and then I add them. So 24x becomes minus 24x becomes plus 24x, and 6x squared at the bottom becomes minus 6x squared. So this becomes 0, and this becomes minus 2x. Okay, that's what's happening there. Let me see if everyone is still with me there. Okay. Okay, someone is saying something there. Mine is a general question. Sorry if this is obvious. I think these chapters 1, 2, 4, 5 were supposed to be studied in 15.10. People, the one that I'm doing now, as far as I remember, you don't do this section in 15.10, right? Chapter 3. You're doing it in 15.11, right? Okay. Okay, Malakalaka. He asked me to please repeat the last step. That's fine, no problem. I repeat that. But one thing I know that this is prescribed for 15.11 this year. Okay, although those other chapters, I think 1, 2, 5, etc., as mentioned in the chat, they are for 15.10. Okay, sorry guys. Okay, so let me just for the sake of the previous student repeat these steps here. Let me just erase this here, guys. Okay, so just erase this here. So with this last step, let's see that last step, okay? Right. So after multiplying 6x, well, I asked the question initially, how many times does x divide into 6x squared? I said 6x times. Then I multiply 6x by x, and then I multiply by -4, so that I end up with this here, 6x squared minus 24x, okay? Right, now I do a subtraction. Okay? So when I subtract, if I say to you, there is 6 and 4, and I say subtract 4, you say, okay, equal to 2. So I'm subtracting this part here that I'm ticking off. I'm subtracting, so there'll be a sign change now. There'll be a sign change. 6x squared minus 6x squared is 0, and minus 26x plus 24x gives me minus 2x. Right? That's what happened there. And then I ask the question again. How many times does x divide into -2x? Well, -2 times, that's relatively obvious. Okay. -2 times. Okay. Then I say, okay, in the meantime, I can bring down this 12 here on top. I can bring the 12 down. This 12, I can put it down here. There's no harm, right? So when I multiply -2 now what I'll do is, so I ask the question, how many times does this x here, how many times does that divide into -2x? I said -2 times. Now I bring down the 12 in the meantime, and then I multiply -2 with x, and then with -4 again. So -2 times x. Let me just show you which one I'm talking about. I repeat these things. It's an algorithm. Now I say negative 2 times x, negative 2x. Then I say negative 2 times negative 4, it's positive 8. And I do a subtraction again. Again, with the subtraction, the signs are changing. This is 0, and I got 12 minus 8 is 4. There's my remainder, 4. Okay? Right. So what do I have in the final analysis? What do I have in the final analysis? I have this, that my original polynomial p of x, my dividend, may be written in this form. Maybe written in this form. So look what we had here. We had our quotient, we had our divisor times our quotient, okay? Or divisor times our quotient. Well, here's my divisor, 6x minus 2. And here's my quotient, x minus 4, right? And my remainder was equal to 4. My remainder was equal to 4. So this was my divisor, sorry, this was my divisor. This was my dividend. Well, the one I started off dividing with was this one. And this happens to be my quotient. Sometimes they interchange these things, okay? And here's my remainder. Remember, I start off with P of x over Q of x, where Q of x is my quotient, okay? So,
Dr. CS?
Yes?
I just want to bring your attention to a few comments in the chat box.
Okay, let me see. Okay, great. Sorry, I always forget. Why do we have to change the signs? Oh, okay. Oh, that one. Please redo it. Okay, I think Nkunu Bongiwe is fine. And then why do we have to change the signs? Because we are minusing the bottom part, so minusing change the sign. Good, there was a response to that question. So I suspected there, Ms. Pram, that person who posed that question was answered because we are minusing the bottom part, so the minusing changed the signs. Okay, there's a response to that question. Is there any other question that I missed? Oh, someone says I'm too fast. Okay, Andile. Andile, my apologies. Are you with us there? Are you fine there, Andile? Okay. Good. I think Lerato answered. Lerato responded. Thanks for that, Lerato. Lerato responded there. Okay. Because we are subtracting. We can do maybe another one. I'll do another example, guys. No stress about it. Okay. I'll do another example. So let me just check my naming here, guys. I don't want to make errors with the naming. So we can call this, this one I'll call the divisor. This one's the quotient, it's the divisor. So, people listen, sometimes they use these interchangeably, but we can call this the divisor. This one is the quotient, this is the divisor, this is the remainder. The main thing is that here, the remainder, the degree of the remainder can be 0, and it must be less than the degree of the divisor. Okay, and the degree of the remainder is 0. The degree of the quotient and the divisor is 1. The degree of the dividend, the polynomial original function, is 2. Okay, that's the main thing there. If you multiply this out on the right-hand side, if you multiply the right-hand side out, let's just multiply and see what we end up. We should get the left-hand side, okay? So just as a check, I'll do another example, guys. I'll look at the chats now again, just to check if we are working correctly. Check the right-hand side quickly, and see if it's equal to the left-hand side. So I'm going to multiply out the right-hand side now, okay? 6x squared minus 24x minus 2x is minus 26x. Then minus 2 times minus 4 is it's plus 8, plus 4 is 12, okay? Right, so everything seems to be fine, okay? Right, so that's what we call there, right? So this one here, guys, I can just give this a name maybe. Let me just change the notation just to be consistent with your book, because some other books use a different way. So I will call this the divisor. And this I'll call the quotient, just to be consistent with your textbook. And this one here, I'll call it the divisor. And then this one, Q of X, is still my quotient. Okay, I call this the quotient. And my remainder stays the same. Okay, so D of X is my divisor function, P of X is my dividend. I'm dividing it with a divisor, and I have multiplied by a quotient, and then I have a remainder. In our case, the remainder was 4. And our divisor, according to your books, way of handling this, they call this one D of X. And my Q of X will be, therefore my Q of X will be this one. Yeah, this will be my Q of X, my quotient. This is my D of X. This is my R of X. Although it doesn't depend on X, but we just write it down. And this is my polynomial P of X. Okay, let me just see the comments in the chat, and then I'm happy to do another example. Okay, let's see quickly. Right, good, great. Oh, the question, Nkunu Bongwe, the question was this. This was the question. It's an example. It asks you to divide that polynomial by that divisor function. Okay. It asks divide 6x squared minus 26x plus 12 by x minus 6 by x minus 4. Okay. So the result was we got that gave us 6x minus 2 times x minus 4 plus 4. And there was my quotient function there on top. Okay. Right. And this one here is my remainder, because there's nothing else you can do to it. But the degree of that, we'll find that the degree of that can be 0, but as long as it must also be less than the degree of the, and which is the case for that 4. That 4 is degree 0, and its degree is less than the degree of the divisor. The divisor is degree 1 in that case. Okay. Right. Let's try another example quickly. Let's just do another example. Let's just do. I'll try and do just one from your book again. Let's just see quickly. So let's say, so find polynomials. In fact, I won't just do the function like that. I'll just do the division. So let P of X. So I'm just changing the wording, guys, but it's the same problem. So yeah, I'll ask you the same as I asked this question, divide that by that. So I'll, from your textbooks, well, from the 6th edition that I have here, let me just see here, guys. So I will ask this kind of question to you. So the steps are just repeated, just the powers that change here and the coefficients. So divide 8x to the 4, so P of X, divide P of X equal to 8x to the 4 plus 6x squared plus 6x squared minus 3x plus 1 divided by the function, the polynomial function, this is a quadratic function, d of x equal to 2x squared minus x plus 2 and here they say find the polynomials q of x and r of x such that p of x is d of x times q of x plus r of x. But that's fine, we know how to do that, that's not a problem. The main thing is, let's start with this long division here. Okay, so I will check the chats afterwards, but just try and follow it, guys. It follows the same procedure as the previous problem. Okay, so let's just see quickly. So let's divide this. So let's start. So p of x divided by d of x is equal to, or well, let me rather write it like this. So that's what we're going to do. Schematation, right? So now we're doing that. Inside here is my P of X. 8x to the 4, sorry. 8x to the 4 plus 6x squared minus 3x plus 1. And this is divided by 2x squared minus x plus 2. Okay? All right. So if everything is clear there, let's see now how we approach this problem. So there's also what we call synthetic division, but I found that many people get confused with that. And I personally prefer the more traditional, the classical approach to this problem. So here, you consider this power here, x to the 4. And you consider this power here, x squared. And now you ask yourself, okay, how many times does 2x squared divide into 8x to the 4? Well, 2 divides into 8 4 times. And x squared divides into the x to the 4 x squared times. Right? And now I will multiply each of these. Hello? Hi? I can't hear you.
Please tell me.
Andila, is it you?
Yes, it's me, sir.
I
Please
didn't
try
hear your
not to be
response
fast.
there. Am I going too fast?
I said, yes, you are too fast, sir.
Is it? Okay. Okay, let me just try it in slow motion then, okay? Let's see. Okay. The reason why I'm going faster is because I've done the previous problem already and it goes the same way. That's why I'm going a bit faster now, okay? Did you understand? Were you able to understand the first problem? Andila?
Yes, I did understand it.
Then you must understand what I'm doing here because I'm doing the same thing.
Yes,
it's just the powers and the coefficients that change. Sorry?
Yeah.
Yeah, it's the same process. That's why we
Yeah.
call it an
Yeah,
algorithm.
no
Okay.
problem.
But okay, let me just, for the sake of, make sure that you guys are on board. Let me start afresh slowly. Okay, I'm gonna try and go in slow motion. Okay, let's see. What was this? Plus 2x. Let's see quickly. Okay, now I'm writing in slow motion also. Okay, good. Let's see. So the main thing here is you look at the power, the highest power here, x to the 4, and you will divide this power, this highest power, in the divisor. You'll divide that into that highest power. Okay. So you look at those underlined terms. So 2x squared divides into 8x to the 4. Well, 2 divides into 8 4 times, and x squared divides into the x to the 4 x squared times. Because x squared times x squared from the laws of exponents is equal to x to the 4, and 2 times 4 is equal to 8. And then what I must do next is multiply each of these out. I must multiply 4x squared by that. Let's multiply 4x squared by that. I must multiply 4x squared by that. So I'm going to do that now. So 4x squared times 2x squared is 8x to the 4 as expected. And minus x multiplied by 4x squared is minus 4x squared. Minus 4x cubed, sorry. Minus 4x cubed. Right? And then 2 times 4x squared. 2 times 4x squared is 2x squared. I just want to arrange these terms in such a way that they are nice. I'm going to write it down, but I'm just going to make a rearrangement because I just want to make sure that the powers belong under each other, okay? So I just want to, what I will do here, guys, I'll just rewrite, everything is correct here. I just want to make sure that the x cubes lie under the x cubes and the x squareds under the x squareds. So I'm going to rearrange my terms a bit. I'm changing nothing really. I'm just
Excuse
changing
me, sir.
our. Hello?
Can I just interrupt you a bit? I'm like, how is 4x squared multiplied by 2x squared?
How is, oh, okay, sorry. Sorry, I was looking at something else. Thanks for that, okay? That is highly impossible, of course, right? It cannot happen. But let me just make an alteration here, guys, the way I write down these things, okay? Thanks for that. Otherwise, I was going to make a big blunder, okay? Let's see quickly. I'm going to leave some space here for the x cube, and I'm going to start the process again slowly, okay? If I work too slow, I forget what I did in the previous work. Sorry for that, guys, okay? Let's see quickly, plus 2. So I'm dividing it. What is this? Minus 3x. You'll see why I'm doing this now. You'll understand this better, okay? Okay, so I just left the space there for the x cube. Right. I just left the space there because there's no x cube there in the polynomial. So let's start the process again. The question that we asked was, how many times can 2x squared divide into 8x to the 4? It divides in there 4x squared. Now I must multiply 4x squared by 2x squared, by minus x, and by 2. Good. Right, I'm multiplying now, right? And then I must multiply minus x, negative x, by 4x squared, and I get negative 4x cubed. Then this is the one that I didn't multiply correctly. Thanks for that. 2 multiplied by 4x squared is 8x squared, of course. And there are my terms. Now I can do my subtraction, okay? This was x cubed here. What did I do? Am I working too slow here? 8x squared, 4x cubed. Guys, I made another blunder here, no? 3. Okay. You just double check there, guys, that you understand that step. And now I'm going to subtract. And now I'm going to, if all is well, I'll do subtraction now, okay? I put like powers under like powers. Remember, when I subtract, there's a sign change. The sign change occurs for all of these 3 terms here at the bottom, okay? So that gives me 0. There's a 0 there, which you don't need to write. And 0 minus that gives me plus that. And then 6x squared minus 8x squared is minus 2x squared. Okay, right, good. So that is how far we are with that. And then we can do this. We won't bring down these terms yet. We'll leave these terms here in the meantime. We don't need to bring them down yet, these 2 terms here. We still have higher powers that will be multiplied, okay? So we don't need to bring them down, okay? So don't worry, we'll check our work, we'll check back and forth whether indeed multiplying our things give us the polynomial on the left-hand side, ultimately. Right, let's see. So now we start the process again. We don't need these zeros here. They're just placeholders, okay? We don't need these zeros here. Right. So we start the process again. It's an algorithm. So 2x squared, again, the same 2x squared, divides into 4x cubed how many times? 2x times. 2x times, okay? Right, because 2 times 2 is 4, and x squared times x is x cubed. Laws of exponents. So you must bear that in mind. Right? Right. So that's sorted. So I repeat the process. So now I multiply this 2x here. I multiply it again with that. I multiply it with that. And I multiply it with that. Okay? So that's what I'm doing now. So 2x multiplied by 2x squared is as expected, it's 4x cubed. And then 2x times minus x is minus 2x squared, right, as expected. And then 2x times 2 gives me 4x. Double check my work, guys. In the meantime, I can bring this down here. I can bring that down. It's okay. There's no harm in it. Then I do a subtraction. There's a sign change. This is 0. This is 0. This becomes minus 4x, so it's minus 7x plus 1. Okay, right. And of course, we see the power here is x to the 1, and the power here is x squared. So I can't divide that into, I can't divide 2x squared into minus 7x plus 2. Okay, so I stop right there. I stop right there. Okay, so currently what I have, if I want to write it in this form, p of x equal to d of x times q of x plus r of x, which was the ultimate question. But of course, I had to perform long division first. I will write it as follows: 8x to the 4, that's the dividend or the polynomial function that's in the numerator that I was dividing into, 6x squared minus 3x plus 1, and my divisor function was 2x squared minus x plus 2, and that was multiplied by my quotient, which was on top there, 4x squared plus 2x, and my remainder, well, it's just minus 7x plus 1. There's it. There's that, okay? So what you can do then in the meantime, you try and multiply that out and add that. Just work on the right-hand side and see if you get the left-hand side. I want you guys to do that now and multiply out the right-hand side and add minus 7x plus 1 and see if you do get the left-hand side. You guys can just tackle that quickly, guys, okay? You guys will confirm for me. In the meantime, I'll address any other questions. Can you please give us another one? Okay. I had hoped that by now you'd understand it, guys, after 2 examples, because it's the same process. Okay, I think I can give you 50. And after 2 examples at this level, you should be fine, guys, okay? You should be. Okay, where's Realabocha? Are you happy that I fixed up my mistake there, no?
Yes.
Okay, great. Thanks for that. Thanks. It's good. I'm happy that you guys can pick up the errors like that. It's good. Okay, so please, guys, multiply out that right-hand side and see if you agree with my workings there. If it's indeed, and then just add minus 7x plus 1. And once you have collected like terms, added, subtracted, did whatever, check if it's equal to the left-hand side. Okay. Okay, then I think there was a question from Nkunu Bongwe. I will do a last one. This will be the last one on just checking long division, okay? I'll do one more. Let me see. Okay, there's this one. Okay, good, okay. Right, okay, there's this simple ones divided by a linear factor. That's okay, it's okay.
So I just checked the answers. The right-hand side is equal to the left-hand side.
Okay, great. Who was that? Thanks, Lebogang. Thanks. People, Lebogang confirms our calculation. So, is there any opposing view to that, or is there any opposing answer? Oh, thanks, Mr. Ngumalo. So I think Mr. Ngumalo also agrees with that. Okay, right. Okay, there's a request for one last example, guys. I'm saying it's the last example in this. Look, I mean, during the course of these discussions, we probably have to perform long division again. But here we're just looking at long division in and of itself, okay? So I think let me just do one more example on this. Just bear with me, guys, okay? So let's get back to the whiteboard. So the right-hand side is indeed equal to the left-hand side. You guys have checked that, right? Okay, good. So let's do another example. They call it example, what was it called? Example 3, né? Yeah. So from that 6th edition, there's this also, yeah. Example 3. So they ask you to divide. They ask you to divide 2x cubed minus 7x squared plus 5 by by x minus 1. So you can see our degree by x minus 3, sorry, by x minus 3. So you can see that the degree of this polynomial here is 3. In the previous case, the degree of the polynomial was 4. And in the previous case, we divided by a second degree polynomial. In this case, we divide it by a first degree polynomial. It's a linear function. The highest exponent is 1. So it's a first degree polynomial, this one here. This one is a third degree polynomial because the highest degree is 3. So it's x cubed is the highest power there, okay? Right. So let me just double check if I wrote this down correctly. 2x cubed minus 7x squared plus 5 divided by x minus 3. Okay, guys, listen carefully, guys, okay? I'm gonna try and be faster because it's the same process, okay? Let's see quickly. 2x cubed minus 7x squared plus 5. We divide it by x minus 3. So the question is, I'm looking at my highest power here, it's x, and my highest power here is x cubed. So I'm asking, how many times does x divide into 2x cubed? Well, 1 divides into 2 times, x divides into x squared, x cubed, x squared times, because x times x squared is x cubed. Okay, so that's fine. And then I multiply each term in the divisor by the 2x squared. So I multiply again. Okay, I multiply now. It's 2x cubed minus 6x squared. And then I subtract. There's a change of sign. So this here, when I do these two, it gives me a 0. Here, there's a sign change with the minus 6x squared. It becomes positive 6x squared. So it becomes minus x squared. Then what we do next, we divide x into minus x squared because this power is still higher. This power is x squared, this power is x, so I can do that division into there. Once the power here is smaller than the power here, then I stop, then that will be my remainder, okay? So, but in this case, we can still proceed with our division, okay? So our question is still relevant. So how many times does x divide into x minus x squared? Well, minus x times, because minus x times x is minus x squared. So it's negative x times. And then I repeat the process. I multiply. Now I say x times x squared is x squared, right? And then negative 3 times negative x is positive 3x. Okay. In the meantime, you can bring down your 5. It has no bearing really, but you can bring it down. Doesn't matter. You can bring down that 5. It's okay. And then what we'll do is we'll add again. Okay, we'll add again or subtract again. Sorry, we subtract. So there'll be a sign change happening here. There'll be a sign change happening there. Okay, we subtract. Okay, so there's a sign change. Remember, there's a sign change, guys. Okay, right. So minus x squared gives me minus 2x squared. And then I've got minus 3x and the positive 5, which I brought down again. Okay, right. Now I'm asking the question. How many times does 2 divide into minus 2x squared? That's the question now. Okay. How many times does it divide into there? Okay, guys, any questions there? So I'm ending up with minus x cubed. Did I do a wrong thing here? There's something wrong here, guys. There's something wrong here. Let's just check our steps that I write down the problem correctly. So 2x cubed minus 7x squared plus 5. I've divided x in there. Yeah, sorry, you saying?
So I was saying the sign for the x cubed, isn't it x divided by, minus x squared divided by x.
Let me just hang on for me, guys. I'm just following all my steps from the beginning now quickly, okay? So I'm just checking because it's not supposed to end like this.
Negative x to the power of 2 must cancel the positive x to the power of.
Yeah, it's supposed to be. But I was subtracting, remember? I'm subtracting, remember?
Yes, you are subtracting.
Yeah.
Positive x.
Oh, yes, okay, yeah, here's it. Yes, sorry, you're right. Yeah, yes, my multiplication was highly incorrect again. If I work too slow, I forget what I did. Are you fine with that, guys? Are you fine with that? People, I was alerted to the fact that I'm multiplying minus, not x, I'm multiplying minus x by x and by minus 3. So I did this part correctly, but I did this part incorrectly. Can you see that? Okay, so this gives me 0. And now I'm left with minus 3x plus 5. Is that right? No? Minus 3x plus 5. Thanks for that, guys. So I just brought the x down. You see here, my multiplication was completely incorrect. I just took x times x instead of minus x times x. Thanks for that. And again, there's a sign change happening here. There's a sign change happening here. Minus and a plus is 0, okay? Right. Now, lastly, so the degree is still fine. The degrees are still fine. So I can divide x into minus 3x. So I'm dividing this x here, this x here. I'm dividing it into minus 3x. It goes in there minus 3 times, okay? And then I multiply. I'll just check out me with the multiplication, guys. I don't know why I'm failing this now. Okay, so x times minus 3x is minus 3x. That's right, right? And then a minus times a minus is a plus. Now I do the subtraction. There's a change of sign here. This is 0, and this is minus 4. That's my remainder. And basically that's that. Okay, that's that. Where is this? Yeah. There's that. Okay. So ultimately, when you write this down, this is what you'll do. You'll say, okay, there's my P of X. We started out with this. Just be aware of the signs, the negative signs when you multiply negative with positive, guys, okay? We show because those blunders are easily, you can commit it easily, okay? And this is my D of X here. And this is my Q of X. And this is my R of X. And you guys can just check whether, again, please, guys, just check whether indeed the right-hand side is equal to the left-hand side. Otherwise, we're going to have a big mess here trying to sort this out. Check whether the right-hand side is equal to the left-hand side, guys, okay? Just check for me. So multiply out this part and then add -4 to it, okay? Okay. And then maybe we can look at maybe some 1 or 2 proofs and then just prove the remainder theorem and the factor theorems. Maybe just prove some of those things and then apply it and then just see how far we can get to the real zeros of polynomials and talk a bit about Galois. And yeah, fine. What is your 3.5 result? Or complex numbers? Then we can do complex numbers after that. Okay. Okay. Do you get the right hand side equal to the left hand side yet? I'm checking here quickly.
Yes, so the left-hand side is equal to the right-hand side.
Good,
Yes,
good.
sir.
Yeah, from what I can, it seems, yeah, né? Minus 7x squared, 2x cubed, 3x cancels that, 3x, 9 minus 4 is 5. Great, okay, good. Okay, guys, it seems correct. I think, guys, apart from this mismultiplication here with the negative x and the positive x, That was the blunder, but that whole blunder would have impacted adversely on this thing. Okay, so that was important that you saw my mistake there. Thanks for that, guys. Okay, I think you guys should be okay with this now. I think it was yeah, Ngunubongiwe. Are you fine with that now? Okay, Mr. Nimalo's fine. Thanks. Okay, guys. Great. Okay, guys, listen. So let me just, before I proceed, because I don't want to assume that everyone else is busy with the division of polynomials, right? So I want to establish from you guys, are there any other questions beyond this or before this that you want us to look at for you? Before I go on to the remainder and the factor theorems, okay? So what we encountered now was just the division algorithm. Remember, guys, with an algorithm, the process are repeated over and over, okay? It's an algorithm, right? So, yeah. Oh, I just want to check with you guys. Are there any questions? Okay, thanks there, Chuna. Any questions there, guys? Maybe on complex numbers or on matrices or what is the other sections on trigonometry that you want to ask me? Guys, listen, regarding the recording, I think Ms. Prum can say more about the recordings. I can't answer that question. Okay, Ms. Prum can answer that question. Okay, right. So let me go on to the whiteboard and then discuss with you the remainder and factor theorems now, which are important theorems. Okay, so what I've done was basically long division, but of course you need that as you proceed. Okay, so let's do the remainder and factor theorems, and we prove some short proofs, and then we see how to apply that also. The remainder and factor theorems. Okay. Okay, so with the remainder theorem, it shows you that if the polynomial p of x is divided by x minus c, then the remainder is the value p of c. Okay.
Yeah, class service.
Hello. Hi. Someone was saying something. Okay. I think
it was just a mic that went on by mistake, Dr.
Oh, okay. Okay, great. Okay. So the remainder and factor theorem, look at this, guys. If the polynomial p of x, if the polynomial p of x is divided by the linear factor, or the linear divisor is divided by the linear divisor x minus c, then the remainder, that r of x, remainder. So this was the function that we had to divide into p of x, the dividend. So if that is divided by this divisor function, x minus c of degree 1, then the remainder is the value p of c.
What's up?
Right. So maybe we can just apply it on. We can just maybe apply this on some problems. We can do the proof quickly. Right. So let's just see something. So if the polynomial p of x, so this is the big one. Let me just remind you what p of x is again, guys. So p of x for us in the previous, in this previous problem, this was our p of x. This was our p of x. And this one here was our divisor because we divided by that. This was our d of x, our divisor function. This one was our quotient function, q of x. And this minus 4 was our remainder function, okay? So just remember those terms, guys, okay? And this was called the dividend p of x, the dividend, okay? Right. So if the polynomial p of x is divided by x minus c, then the remainder is the value p of c. What was our polynomial? Our previous case. For our previous case, let's see if we can apply it. Our previous case, p of x, and let's see if it works under this theorem, okay? We want to apply this theorem now, okay? So for our previous case, p of x was equal to 2x cubed minus 7x squared plus 5. So if the polynomial is divided by x minus c, we divided it by x minus 3. Right? So x minus c for us was x minus 3. We divided in the previous example, we divided x minus 3 into that p of x, into that dividend, okay? That's what we did. So now we want to check whether this theorem is correct for our case. Then the remainder is the value p of c. So let me just make this note here. For us, x minus c for us was x minus 3. We divided that into that. Their conclusion says the remainder is the value p of c. What is c equal to here, guys, for us? What was c equal to for us? What was c equal to? If this is x minus c, this is x minus c, what is c equal to here in x minus 3?
3.
Good.
3.
C is equal to 3. They say that the remainder of the value, then the remainder of the value is the value p of c. What was our remainder? Minus 4.
Minus
right?
4.
Good. Our remainder was minus 4. Our remainder for the previous case, our remainder, or r of x, was minus 4, was negative 4. So they say all you have to do, you have to calculate p of c, and that's your remainder. So p of c is equal to p of 3. And now I substitute p of 3, I substitute the 3 in here. And I calculate it. And for us, you said it was minus 4. So now in p of x, I put p of 3. P of 3. 2, 3 cubed minus 7, 3 squared plus 5. Remember, you said we must get minus 4, right? So 2 times 27 is 54. Minus 7 times 9 is 63. Plus 5, that's 59. Minus 63. And the theorem holds. It's minus 4, as expected. So that's the beauty of that theorem. Okay? You can already predict what the value of the remainder is before you started with the problem. Okay? You can already predict that, what the remainder is. Just before you started with the problem, we will also do a check. So this was a check on example 3. We were checking example 3, whether our example 3 was consistent with this theorem. It says if the polynomial p of x, in our case p of x was 2x cubed minus 7x squared plus 5, if it is divided by x minus c, and c for us was 3, then the remainder according to the theorem is just the value of p of c. You substitute 3 into p for our case, and we found it indeed, it's minus 4. which was indeed the case. Our remainder was -4. Okay. So you'll appreciate that theorem, guys. Okay. Right. So do you guys want us to prove that remainder theorem quickly? Are you fine with that for proof? Can we prove that? Or should I look at another example of ours and see if the remainder theorem predicts it correctly? Maybe before I prove it, okay? Let us look at maybe our example 2, and let's see what our remainder was for example 2, and then see if we apply the theorem again, okay? Let's just look at our example 2 there.
But our example 2 was not x minus 4.
Oh, it was not a linear function. It was not a linear function.
We can look at example 1. It was
example 1. Good. I like that. I like what you said now. Because let me just check the example 2 again. And I'll tell you why she says what she's saying, guys. She says, well, you see this theorem, you must read it carefully. The division occurs here. The division occurs here by a linear function, x minus c. The highest power is 1. X to the 1, the highest exponent is 1, sorry. So what she says, which is she's correct, this is not squared or cubed or to the 4. This only holds for the case where it's divided by x minus some constant, okay? So she's very correct with that. You must choose your problems carefully to which you must apply this, okay? So I have just forgotten what we did with example 2. Let's see. We divided by a quadratic function. Can you see that? We divided by a quadratic function. So we can't apply, that theorem is not applicable here because of this here. Can you see that, guys? We can't apply it. So she said, we must go to example 2. That's example 1, sorry. Yes, example 1, she says. Why? Because look at example 1. We divided it by x minus 4. Okay? We divided it by x minus 4. So now I want us to use example 1 and see if the theorem is still applicable for us. Right. So for example 1, so check. So we're looking at this theorem. Remember, we're looking at the remainder theorem, right? If the polynomial p of x. So for example 1, so this was example, what was this? Example 2, no? What was this? Example 3. This was for example 3. I just want to note this down, guys. This was example 3. And I just want to say, example 2 is not covered by the theorem. By the remainder theorem.
Sir.
Yes. Yeah.
Will the equation always be x minus a constant number? It will never be x plus.
Can you just repeat that question?
I'm asking if the linear equation will always be x minus a constant number, or sometimes it's gonna be.
Yeah, that's how it appears. Yeah, that c represents a constant number. Okay. And it's x minus that constant. It's not x squared minus that constant. It's not x cubed minus that constant. You understand it? That c is just it's a real number, fixed real number. Okay? So fixed constant.
Sorry? So there was a question.
Oh, okay. If the divisor was x, okay. Sorry. Yeah, Lerato is a question. Sorry, guys. Lerato is a question here in the chat. If the divisor was x plus 3, in that case, is the c in that case -3? Of course, it's -3. Good one. People, there's this question. It says, if the divisor was x plus 3, is the c in our theorem then? That will be -3. You are correct. Okay, good. So we will look at example 1 now. What else? Someone made another comment there, guys. I didn't pick that up. So what should I write here, for example, 2 is not covered by the remainder theorem. What should I say here, guys? Anyone? What do you propose I say to someone that asks me, why is it not covered? What must I write here?
I would say, like, let me try. I would say example 2 is not covered by the remainder theorem because example 2 divisor, it is a quadratic.
Good, good. Since the divisor is a quadratic function, right? That's all. Since the divisor is a quadratic function or is a quadratic. Good. Because that thing deals with linear functions. Okay. So it's x minus a constant. Good. So it's not covered by that. Let's look at example 1 and see if the theorem is correct for our case, if we will get that answer. Okay. Compare example. So example 1 in relation to the remainder theorem. People, I'm just going to say RT for remainder theorem, but don't do this in the exam or assignments and write RT and the lecturer doesn't know what it means, okay? It's just for me to save time. So example 2 is not covered by the remainder theorem. Example 1 in relation to the remainder theorem. Now we'll test example 1, whether it satisfies, whether that result is true in the context of the remainder theorem. Let us see what our function was for example 1. So now we're just applying the theorem and seeing whether we work correctly, okay? Which we knew we did because we checked everything. So our function P was 6x squared minus 26x plus 12. Write it down. When we apply it, okay? P of x was equal to 6x squared minus 26x plus 12, and the divisor function d of x was x minus 4. Our remainder, what was our remainder there? Our remainder was equal to
Positive 4.
Positive 4, thanks. Our remainder was 4, né? Good. Now, the divisor theorem says that the remainder theorem says, sorry. So people, let me just be very specific. The topic is called the remainder and factor theorems. This one here in particular is the remainder theorem, okay? We will come to the factor theorem. But what we are dealing with here now is the remainder theorem. The subsection is called the remainder and factor theorems. So let me just to avoid confusion, let's take this away in the meantime. We'll come back to the factor theorem. Otherwise, people might say, but you said the remainder and factor theorems. So this is the remainder theorem. We'll come back to the factor theorem, okay? Right. So this is the remainder theorem. So if the polynomial P of x is divided by x minus c, right, then the remainder is the value P of c. What is c equal to for us, guys? Our case, what is c equal to for us?
4.
It was 4, right? 4. Right. C is equal to 4. Right. The remainder was also 4. So we must get P of C, P of 4. And the answer must be 4. So let's put P of 4. Let's calculate P of 4, guys, and see if we get 4. 4 squared minus 26 times 4 plus 12. 6. Let's see what we get there. 6 times 16 is 96 minus 26 times 4 is it 10? 4 plus 12, no? Let's double check. No, that's too much. I'm missing something. Was it 106, no? Is it right? Just double check for me there, guys. Is 104, no?
Yes, sir.
Okay, why does it look so big now? What is the answer there?
It's 4.
The answer is 4.
Oh, okay. Now it looks odd. Okay. Oh, okay. Because I subtract. I thought it was. You know what? I thought 104 was positive now, so I thought no, it won't work. So it's minus 8 plus 12 is 4. Can you see that, guys? As expected, right? As expected. So the theorem again confirms our belief in that. So it means that we can do any problem and already predict the remainder. If we know C, we can already predict what the remainder is, okay? Do you understand it, guys? Great. Okay. Great. So what I'm going to do, let us predict a remainder and then do the work now, okay? So I want you guys to be clued up, and then we will do the factor theorem after this. So one more example. Now we'll have a problem where we will do division, and then we will predict the remainder, and then we will do long division and see if that is indeed the remainder. So we'll work the other way around now, okay? So firstly, we started doing long division, and then we found we had the dividend function, we had the divisor function, we found the quotient function, and we also found the remainder. Now we will be given the polynomial function p of x, and we will be given the divisor function, and now we will predict the remainder, okay? Right, okay, and then we'll test that result. So let's call this example 4. And then we'll see if using the remainder theorem to find a value there. So yeah, p of x is equal to 3x to the 5 plus 5x to the 4 minus 4x cubed plus 7x plus 3. It's an awkward looking function. And we will divide this by okay, let me say find the remainder. Find the remainder of when this is, find the remainder of this when this is divided by, find the remainder function when this is divided by, when p of x is divided by x plus 2. Question, what is my C there, guys? What is my C here? What is my C in here?
-2.
-2. So because x plus 2 is equal to x minus -2. Remember, the remainder theorem says you must divide it by x minus c, okay? X minus c. So we must find, what value must we find now? What is our c equal to? -2, right? C is equal to -2. So we must find p of c for the remainder, or in our case, find p of -2. Guys, can you quickly calculate p of -2 there, and then we do the long division quickly. So I want you to find this, and then we'll confirm with long division, okay?
The answer is 5.
Is it okay? We'll double check your work, no?
Okay.
Right. Okay, guys, let's see. She said the answer is 5, no? She said the remainder was 5 according to her. Let's see. So this is minus 32, so it's minus 96. And this is 16 times 5 is 80. And this is this is plus 32. And this is minus 14, and this is 3, right? So it's minus 16, so it's 16, 14 is 5. Okay, so we get 5, guys, okay? So we're just testing now. Now we will do one more long division. We'll do the actual long division and see if we indeed get 5, okay? Right, so we will divide this into there. Okay, let's see that, guys. Right, let's see. So it's x plus 2. And then we have 3x to the 5 plus 5x to the 4.
What's that?
Minus 4x cubed. Guys, can I ask you that the people in the background there? Can I just request, guys? Can I just ask that? People, can I just request that you try and have a space that's quiet, because it does impact on our concentration, okay? And I think it's fair to speak on behalf of others. It's not nice to do the mathematics under those conditions. So just try and keep the environment around you quiet, guys, okay, as far as possible. If you can't, then just just turn down your volume or the mic, okay? And we don't need to hear the background noise. Thanks, guys. Right, let's see. Okay, so right, let's see quickly. Minus 4x cubed plus 7x plus 3. Let's do this division now. So this is quite long, but it's the same process, okay? So again, the question is, how many times does x divide into 3x to the 5? 3x to the 4 times, okay? Now I multiply out all those two, there are two terms there. Those two terms in the divisor, I multiply them by 3x to the 4. I get 3x to the 5 plus 2x to the 4. Now I subtract. Okay, I subtract. I've got 3x to the 4. Then I divide x into 3x to the 4. I get 3x squared. Then I multiply again. Oh, I made a blunder already. Can you see my mistake there? Guys, can you see my mistake there?
Yes.
Great. There, is it corrected now?
Yes.
Is it fine? Good. Sorry for that. And you see, it will have a bearing on everything that follows there. Okay. So just double check my work as I go along, guys. Okay. So 3x to the 4 times x is 3x to the 5. 2 times that is 6x to the 6x squared. 6x squared. Just make sure, guys, you agree with me there. And then yeah, I must just get rid of this. Oh, did I multiply the wrong one there now? Okay, just let's see, guys. So x goes into 3x to the 5, 3x to the 4 times. 3x to the 4 times x is 3x to the 5, and then 2 times that. Oh, it was fine. It was 6x to the 4, right? Now I subtract. Just double check it, guys. Now I subtract. This is 0. This is minus x to the 4. See if you agree, guys. No? See if you agree there, okay?
Yes.
Great. Now x goes into minus x to the 4 times minus x cubed times, right? And then I multiply again. Minus x to the 4 minus 2x cubed. In the meantime, I can bring this down here. I can bring the minus 4x cubed down. See, I can bring that down. Here. I brought down this one to there. Okay, that's what I did. So I multiply out minus x to the 4 minus 2x cubed. And now I subtract again. There's a 0 there. There's minus 2x cubed. Right? There's minus 2x cubed there. Are you guys happy with it? Né? Then I say, okay, that one goes in there. Minus 2x squared times. Then I multiply again. Minus 2x cubed. Right? Minus 4x squared. Minus 2x cubed minus 4x squared. I subtract again. In the meantime, I can bring down those other terms, but it's not a real problem. When I multiply that out, I get that. So I subtract, that's a 0, and I get plus 4x squared. Okay. Now I can say x goes into 4x squared plus 4x times. Plus 4x times, it's 4x squared plus 8x, right? In the meantime, I can bring down 7x and the 3. I bring this down here. Then I subtract. And I get minus x plus 3. Okay. Now, x goes into minus x minus 1 times. I've got minus x minus 2. Now I subtract. And I remain with 5. Okay, and there's the expected answer. The remainder was indeed supposed to be 5, and it gave us that 5. Okay, right. So guys, can you see it's like an algorithm? You just repeat the steps. You just have to keep track of the exponents. Otherwise, you can commit an error easily. Okay, so you saw the errors I made there just by multiplication. On the other end, it's not so bad. It's just a repetition of steps. That's all. You must just make sure you adhere to your laws of exponents. I did this because I wanted us to see how that remainder theorem is applicable. We predicted the remainder beforehand, before we even did the long division. Okay, we could predict that 5. So my question is now, guys, what is my quotient function here? What is my quotient function here? Anyone?
Open brackets.
Okay, now just tell me. You should see it. I want you to tell me what's what do you see in front of you? What is the quotient function? What is Q of x?
3x to the power of 4 minus x to the power of 3 minus 2x to the power of 2 plus 4x1. Good, good. People, this is it. She said it correctly there. This is the quotient function. This one is my divisor function. This is my so-called dividend function, although I don't like it. It sounds too accounting-like. And this one is my remainder function, r of x equal to 5. Okay, right. So I wanted us to look at the factor theorem. It's a very obvious theorem also. If you want, guys, we can prove the remainder theorem quickly. Otherwise, we can leave it maybe for the next time I see you. We can perhaps do it some other time. Yeah, then I will look at maybe the proof of the remainder theorem and then application of the factor theorem, and then go on to complex numbers. Okay. Oh, then look at the real zeros of polynomials. And then at least now I know where you guys are. So yeah, I can just prepare accordingly. Because I was hoping we could start with complex numbers today, but that's fine. It's not a problem. Okay. So let me just check. Is there any other questions that you have there? I think I initially spoke to. Yeah. People, are there any other questions? Oh, Larato, you said 6x to the 4. Oh, you were just trying to correct me on something. Thanks for that. Okay. If the divisor was okay, good. That's fine. Guys, are there any other questions? Otherwise, we can proceed. At least I have an idea where you guys are. Yeah, I think it's fine. The factor theorem. The factor theorem is quite short. There's the question: do we need to know the proofs by heart? Look. This is a so-called pure maths module. Okay, so it's always good to know the proofs. It always helps, and the results, what they say, and so on. I don't know what the lecturer stated in your learning guide. Perhaps I must just go through it again. But I mean, if I was giving a pure maths course, there'll always be some proofs. Okay,